Hello student, now we start our next point, concept of capacitors, means capacity of capacitor. Okay, so last week we learned about potential energy, and now we learn a capacitor. Okay, so capacitor is the system consists of two conductors having equal and opposite charges separated by an insulator, means insulating medium, or dielectric. So the electric field in the region between two conductors is proportional to magnitude of electric charges. This is the negative and positive charges. Besides, the potential difference between two conductors is proportional to the magnitude of charge Q. So V is directly proportional to Q. The capacitance of capacitor is the ratio of magnitude of charge the magnitude of potential difference between two conductors. Obviously the conductors giving negative and positive charges. Here negative and positive charges. So C is equal to Q upon V. The ability of conductor to store an electric charge and electric potential energy is called as capacitance of capacitor and act as small reservoir of energy. The word capacitor is used sometimes, and which is misnomer, as capacitor does not condense energy as such, but it stores an energy. So capacitor means the stored of energy. So the SI unit of capacitor is 1 farad, is in honor of Michael Faraday. So 1 farad is equal to 1 coulomb upon 1 volt. So a capacitor has a capacitance of 1 farad if the potential difference across it rises by 1 volt when a 1 coulomb of charge given to it. So 1 microfarad is equal to 10 to minus 6 farad, and 1 nanofarad is equal to 10 to minus 9 farad, and 1 picofarad is equal to 10 to minus 12 farad. Okay. So the concept of parallel plate capacitors. So parallel plate capacitor means here two conductors a small distance d. So a parallel plate capacitor consists of two parallel metal plates, each of area A, separated by a distance small d. Let positive charge Q be the charge on insulated metal plate P1. When it is fully charged and V is its potential, then its capacity is given by C1 is equal to Q upon V. So C means capacitance of the capacitor, means conductor, and Q is the charges and V is the potential. Now another identical metal plate P2 is kept parallel and near to the metal plate P1. Then inner surface of metal plate P2 acquire charge minus Q. This is the inner, and for far side of outer surface of metal plate P2 acquires charge plus Q by induction. So here negative charges, here positive charges. The induced negative charge lowers potential of plate P1, while induced positively charged raises its potential. However, being nearer to plate P1, there is net discharge in potential plate P1. So now the outer surface of P2 is each connected free positive charge plus Q on outer surface of P2 escape to earth. Let minus V1 be the electric potential due to charge minus Q on plate P2. So hence net electric potential of system is plus V plus minus V1 is equal to V minus V1 because of V minus V1. So the capacity in this case C2 is equal to Q upon V minus V1 because we know that C is equal to Q upon V formula. So capacity in this case is C2. The plate does C2 is greater than C1 because denominator of equation C2 is equal to Q upon V minus V1 is less than that in of equation C is equal to Q upon V. And second, numerator of equation C2 is equal to Q upon V minus V1 and C is equal to Q upon V is the same. Thus, capacity of meter plate P1 is increased by keeping another identical earth connected meter plate P2 near it. Such an arrangement consisting of two identical conductors, one of each is positively charged and other earth connected is called as capacitor. So this concept is called a capacitor. Since the arrangement consists of two parallel meter plates, it is called as parallel plate capacitor. So capacitor means is the parallel plate cap. So if we here understand what is the capacitor. Capacitor means to store the energy for temporarily, not constantly. Okay. So capacitor is the store of energy is called a capacity of capacitor. So with the formula is C is equal to Q upon V, where Q is charge is on capacitor and V is potential. Okay. So now next point is types of capacitors. So first one is parallel plate capacitor, where parallel plate capacitor consists of two parallel metal plates, each of area A separated by a finite distance d, small d, connecting dielectric between them. So one of the plate is positively charged and another is connected to earth. Now next type is cylindrical capacitor. Now cylindrical capacitor consists of two coaxial cylinders of radius A and B respectively. Here A and this is the B. Outer surface of inner cylinder is positively charged and inner surface of outer cylinder is acquires negatively charged. Okay. Last lecture in parallel plate means here considering two conductors. Now here cylindrical means two cylindrical conductors. A medium of permittivity is epsilon. Epsilon is present between the two cylinders. So in the between this cylindrical is the epsilon. The outer surface of outer cylinder is earth connected. Now your third type is spherical capacitor. The spherical capacitor consists of two concentric spheres A and B. The outer surface of inner surface is positively charged and inner surface of outer sphere acquires a negatively charged by induction, and outer surface of outer sphere is connected to earth, is earth connected, and a medium of permittivity epsilon is present in the space between the two spheres. Then parallel, cylindrical or spherical, all these types of capacitor, permittivity epsilon is present in the space between the two spheres. Okay, so we understand the types of capacitors. So three types of capacitor: parallel, then cylindrical, and then spherical.